addition reaction. So addition reaction involves breaking a carbon-carbon double bond, sometimes carbon-carbon triple bond, but it's more likely to be alkene rather than alkyne. Okay. So a single bond is formed as well as a new bond is made at each of the carbon that makes up the carbon-carbon double bond. One product is produced in addition reaction. So in this case, it's 1 + 1 = 1, which is a little bit weird. Okay. Here is a reaction mechanism. We have hydrogen chloride adding to a ethene. You will see that one double bond broken, and hydrogen is added to one side, and chlorine is added to the other side. So notice that although hydrogen chloride cannot participate in substitution reaction with alkane, but it can be easily added to alkenes because double bond increase the reactivity of hydrocarbons. Okay? So if it's in a chlorine molecule, you would produce 1, 2, because it has to be a new bond formed at each carbon. It can't just be added to the one carbon. It has to be one and the other one. Okay? Common inorganic molecules that can be added include halogens, hydrogen halides, and even water. Okay? For example, halogens. Bromine, normally in a brownish red liquid, can be added to just ethene here. You don't have to say ethylene, just ethene. And then become 1,2-dibromoethane. Remember, one new bond is made at each carbon. Okay? So this is the reaction of a very famous bromine test used to identify unsaturation, namely carbon-carbon double bond in hydrocarbons. So if you add bromine to a unsaturated hydrocarbon, then bromine can be added to the double bond, and therefore the entire test tube, whether the organic or inorganic part, will be colorless. However, if you add bromine to a saturated hydrocarbon, so alkanes, then nothing is going to happen. Bromine might dissolve more in the organic part or the inorganic part, but the thing is that nothing will happen. Okay? The brownish liquid will remain brownish. So this is the bromine test. Very useful, very easy test to distinguish between alkane and alkene. Here is a reaction mechanism of adding water to ethene and therefore produce alcohol. Again, hydrogen is added to one carbon, and the OH, remaining part of the water molecule, is added to the other. So again, this is the second method to produce alcohol from hydrocarbons, adding water. Remember, the first one is to substitute haloalkanes with using base, strong base, like sodium hydroxide or potassium hydroxide. Okay? The full reaction equation of adding water to ethene is written in this way. You see that this reaction condition is also very unique. It requires a lot of things. It requires an acid, a catalyst, and a very high temperature, which means in this reaction, water will be gaseous. Okay? Notice that because of this condition, sometimes in reaction pathways, I could just give you this condition without telling you what actually happens, but you would know that it's an addition of water to a alkene, not just to ethene, to any alkanes using the same reaction condition. Well, hydrogen gas can also be added to a double bond. Okay? Here we require nickel or sometimes platinum, these kind of metal solid, as catalyst. Okay? Here is a reaction mechanism. It literally shows how heterogeneous catalyst, that is, like the reaction is actually happening between two gases, but the phase of the catalyst, platinum, is solid. But the solid catalyst will then produce a place for the reactant particles to meet. Here it is. Okay, So solid catalyst here, trapping the hydrogen gas so that ethene can come here and easily meet with the hydrogen gas. In that way, it speeds up the reaction. Okay. Here I have to say this again. So benzene, sometimes written in a way that's a hexagon ring with alternating double bonds, but it actually does not have double bonds in its ring. So benzene, although it's sort of unsaturated, but it doesn't really have double bonds in there, and therefore it cannot go through addition reaction, especially definitely not with hydrogen to become a cyclohexane. Okay? Not in VC chemistry anyway. So multiple double bonds can also be added onto each other. Since, for example, since this double bond can break, then each of the carbon will have a extra hand to hold another molecule of ethane and therefore be connected together. So polymers are therefore formed, and polymers are named after its monomers. So if it's ethene making a polymer, then you just add poly in front of it. If it's propene, just add poly in front of it. Okay? So polymerization normally requires a catalyst.